I do these, I never know what's going to happen. And I got clocks around me, so I'll be able to track the time.
Okay. Well, we do have a minute past, so I'll continue to let people in, but in the interest of time, I will kick us off. So thank you guys very much for joining the, I believe it's the 6th edition of the GIS Informational Series for our 2025 series this year. And we are very happy to have Richard Kelly and Jeff Young here from One Spatial. They're going to take us through Next Gen 911 GIS Data Model version 3. And as a reminder, this is being recorded. The only official version of this meeting is the one that it will be produced by the PUC and put onto our YouTube. And we will also make the materials available after, or actually they're already available on our Colorado 911 program website, so you can follow along. I will also, we do not have a chat. And so if you have a question, please use the raise hand function, and then you'll have to unmute to ask your question. And I will let Richard let you know how he wants to take questions. I'll also be recording all of our questions and putting it into our Q&A session at the end of October. So with
That'll
that,
be good.
Richard, the floor is yours. Thanks very much for being here.
No, I appreciate it. And we're glad to be here supporting this series of presentations for the folks of the state. It's very important that we all work together to provide this information. Hopefully, my voice is strong right now. If it weakens due to connectivity, let me know, and I will try to make sure we're up to speed on volume. Okay? With that said, we'll get right into the presentation. Today, we wanted to wrap up several presentations that have been made talking about Next Gen 911, GIS data use, its importance and role in multiple areas of 911 in the future. We'll talk about a lot of acronyms, Next Gen 911, Next Gen Core Services, and how GIS data factors into the environment in the future used for call location termination, call routing, services determination, things of that nature. As we said, there'll be a lot of questions that can be answered after all of these sessions are completed. Let them know that you have some questions. We're glad to follow up. Wanted to level set again. We've had a lot of discussions on other calls, not only for myself, but other colleagues and other companies that I know that have gone through some of this discussion. This is a reminder that there are many documents that are provided by the National Emergency Number Association that basically frame out how to build applications, how to provide services, and how to conduct operations for public safety in North America. And I say that deliberately because it's both the United States and Canada. You'll see here that we're going to focus on the NG91 GIS data model. It has a code of STA-006, which stands for standard number 6. We're at version 3. We'll talk about that in a little bit. But I want you to note that that model, that singularly, has an impact on many other standards and guidance documents. At the top left, you're going to see the Civic Location Data Exchange format. That is the alley replacement in the future. Basically, the location information, the caller, all of that is conveyed in a new format rather than the 512 alley character string that we're used to. Also, there's a variety of documents on stewardship, how you manage and build geometry. The data model focuses on the attribution, if you will, of GIS data. But we're also expanding not only the geometry and the attribution, but also the three-dimensional perspective. So you'll see on the far left, there was a requirements document built that combined all of our existing knowledge on 3D as it applies to GIS data going forward. That'll be a new horizon for us. I'm sure the folks in Colorado, you guys will want to hear more about that as it evolves, but the data model is going to embrace that eventually as the time moves on. We'll also talk about some of the functionality. Notice there's a dashed line here. This is a NENA-backed effort throughout this area. However, APCO also has interests in working on computer-aided dispatch, CAD interoperability. They have a work group underway to look at GIS tags. What's nice about that is a lot of the folks that work within the APCO standardization effort for GIS tags or identifiers in the database also work on the NENA GIS data model. iterations that come out. So that'll add a degree of consistency. Myself, Richard Kelly, I've worked, I think we've talked about this on previous calls. I've been in the industry now since probably 1997 doing public safety 911, but doing GIS professionally for about 30 years now. My roles have gone from working in regional government here in Texas at the county and the regional level, working with the state and federal agencies on GIS data development, coordination efforts, applying for funding. I've written RFPs, I've responded to RFPs. I've been in your shoes on how to develop and build databases from scratch and how to acquire goods and services in support of that. I've also been on the private sector side. Right now, I represent, you see the template here, One Spatial, but I've also worked previously at Motorola. I've worked at 191 Data Master, where we worked on traditional database deployments, and of course, before that, with other call handling equipment vendors specializing in GIS and map displays, as well as CAD integration. So the content I'm going to give you will really be, I guess, a consolidation of all the efforts that I know I and others have put in over the years. I try to use this train analogy. It seems to be one of the better metaphors for what we're working with on building out guidance for how we're building these systems and the data that needs to feed into them. If you look at the little graphic at the top, you'll see a locomotive engine on the far right, STA010. The I3 architecture is its name. What's important, and as the train goes from right to left in the different cars, so does the list top to bottom below it. And what I try to do, this is going to be your cliff notes. You don't have to read the thousands of pages of standards I have, and a few hardy other individuals have as well, but we'll try to give you guidance where you go right to what you need as you're building and managing your own GIS data operations. The I3 standard has a number of things that will directly impact what you have to build and manage on the GIS data side. Right now, 3.1 is in development. I think it's version E. They're going to have a few changes in there. We'll talk about that. Below that, you'll see that the CLDXF, that stands for Civic Location Data Exchange Format, there's a version for the US, which is a version 2, and there's a version for Canada because there's a few differences in how location information is conveyed. Think of it like an address. And that's at version 1. That just got updated fairly recently this year. There, the 3D location data requirements, I mentioned that REQ came out. But I also want to let you know that there is a 3D GIS standard that had its first meeting, I believe it was last Friday, and it's going to move forward doing its work and trying to give us a framework for how to build and utilize three-dimensional data. If you're looking at BIMs, building information models, doing floor plans with heights, looking at LiDAR for how to represent three-dimensionally a interior structure, all of that's going to be taken up by that new model. It's not listed here, but you can basically think of that as a new model for GIS data that's slowly working its way into the GIS data model in the future, maybe a year or two down the road, when version 4 is built. That won't start for a while, so the 3D model group will be working right now. That's why we talk about the GIS data model. You'll see right under the 3D REQ. And that public review has been completed, and they're adjudicating the comments. What I will tell you, we'll get to this, the data model is going to be, I would say, likely released before the end of the year, maybe in the next few weeks or months. When that's done, that'll be a watershed event for those of you like me who've been involved with it since about 2010 when the first iteration came out. When this version 3 comes out, it will have some major changes and updates that I would not expect to see change in quite some time. We have states across the U.S. and parts of Canada that do not want to see that change again, because if we change schemas, you all know from your database knowledge, you start messing with schemas, the column widths, types, names, it messes up your operations. I would see the data model V3 will stop a lot of that for a good long time. The stewardship document, INF028, as a reminder, that's going to tell you how to build the geometry. Okay, and then there's a GIS data transition document, which came out as well not too long ago. That's going to tell you how to get from where you are today, whatever state your GIS data is for your 901 program, to where it needs to be for the future, the 21st century, for supporting geospatial operations and routing of calls. And then finally, There's a work group that I'm co-chairing with a couple other colleagues, Brooke Shannon from ESRI and Megan Cisco from the state of Minnesota. We are working on this utilization of GIS data and next-gen core services. One of the things that is not covered by the I3 standard at the top, that is not covered by the data model, that is not covered by the stewardship, and is not covered necessarily by the transition, is how GIS data is used in each one of the functional elements in NG911. And we're going to cover some of that today. This diagram I'm bringing up now, and again, you guys don't have to write any of this down. I've provided leadership here to have a copy of this deck in PDF. You may have it afterwards. They can give it to you now or later. So all these slides will already be in your hands. The information in it is publicly available. So everything you see, I'll have citations typically of where it comes from. A good example of that here, where you see green bold, those 6 character designations for standards. Each one has a 3-letter designation. If it says STA, it's a standard. If it's REQ, it's a requirements. If it's an INF, it's an INF or informational document. If it doesn't have something before it, it's pre-standardization within NENA, like 71501 on the far right. What I wanted to let you know is that, and a reminder, most of you already know this, GIS data is the watchword for NextGen 911. It's everywhere. So these standards I have, and this is my cheat sheet, if I'm building out a forest guide on the far left, or if I have to, a statewide forest guide or a national, or the spatial interface in the mid left, or if I have to understand how my location validation function or my ECRF at the top, or even how I build data upstream, how I have to provide downstream to the bottom left my map display or my CAD system and PSAP. There are guidance documents I need to refer to know what format the data should be built towards. So this is my way to go. The highlight here in yellow illustrates the GIS data model V3 affects all of these components you see on screen. Okay. When we go to the next slide, I want you to understand that, again, if it's a dark green bold top left, that's the standard version, the name you can use to look it up. You go to the NENA website to look up the standard or guidance document, or you can just Google it. What I show you in the blue bold are things I want you to keep track of as acronyms you should know going forward, because either you're going to have to acquire or manage these functional elements in your next generation 911 environment for your city, county, state, or you're going to have to build data for it. In the I3 standard, which again is like the Bible for everything, understand that all data, GIS data, has to be in World Geodetic System 84, WGS 84. So if you're dealing with a state plane coordinate system or datum in Colorado and you have a projected coordinate system, whatever it is that utilizes that datum, bear in mind you're going to have to convert out to WGS 84. We'll speak to more of that in a little bit. But if you look at these, we're going to want to be aware that the SI is going to be utilized for layer or GIS data replication. We saw that in the previous example. Think of it as the Grand Central Station, to continue our train metaphor. All the cars for data will come into that SI and go everywhere else, radiating out from there where it needs to go, whether it's a map display system or an I3 functional element like the LVF or ECRF. Discrepancy reporting will be a big part of that. Section 3.7 describes discrepancy reporting on GIS data as well as many other items, but discrepancy reports as it applies to, let's say, the spatial interface. If there's a failure of GIS data to load properly or something happens, that discrepancy report, or DR, will be provided via web service. We won't speak much of that today, but that's always a good topic for later to discuss how we do discrepancy reports for GIS data. It's always been a goal, and I've struggled with this with many other organizations. I've worked with states all over the country and some folks in Canada. How do we vet our data and how do we manage it when problems come up during operations? Discrepancy reporting will discuss some of that. The emergency call routing function and the LVF, they're described in section 4.3. The MSAG conversion service, you may not have heard much about. That's going to be the element that helps you convert from a next-gen location, let's say a call center, a PSAP, public safety answering point, or an emergency communication center, ECC. You'll hear me use those terms together. So the MSAG conversion service converts the location metrics and information from one format to another. We may have to have it in basically a 512 character ALI format, or we may need to have the next gen every kind of field possible in it, as stipulated in the civic location data. That MCS change and power, it's fueled exactly what it sounds like. We have to be able to geocode. As you know, for those of you who've built geocoders, it can be complicated. Boyd Avenue, where you have a camel case where you have lowercase and uppercase in the same name, or there's hyphens, St. John's, where there's abbreviations and street types as part of the street name. That geocoding service has to utilize and handle those kinds of anomalies, but look GIS data being used, whether it's address points or if it's from center lines, and we have to geocode and reverse geocode. We'll talk about that, but that's covered in the I3 standard, as is the forest guide. We won't spend much time about that today. Think of that as a national lookup for where every call routing server, basically ECRF, is in the United States or Canada. It can forward those out of area calls to the correct location. The mapping data service, we also won't describe much today, but essentially it's like a Google map for next gen 911. The mapping data service, or MDS, is also powered by GIS data that you'll probably have a hand in building or propagating. Right now, there's also a GIS layers registry in section 10.3.2 in this document. There are 51 layer names, and I'll show you an example of that in just a second. Those layer names are what's recognized by the NGCS systems, particularly the mapping data service, to grab, use, download, promote. It's important to know what those names are when you need them. Finally, Appendix B, which has been around in the first several versions of the I3 standard, that has been removed in version 4. That was machine-to-machine communications of geographic information. That has been added and integrated into the data model v3. That took out several dozen pages out of the I3 standard, which is back down to a healthy 700 or 800 pages, if you want to read this by itself. And all of this content, I'll say it again, is taking thousands of pages of documentation, distilling it down to things that you can use as guideposts of where to go. Now, I will tell you the standard for the NG91 GIS data model at version 3, it's going to, as I said, it's already in alignment with the I3 V3 standard we just briefly discussed. It's moving to support 3D GIS in the future. Its first step towards that is providing support not just for points and lines, but also polygons for information related to civic. So if you have a building footprint or a room footprint, that will be able to be supported in there. As I said, it'll support CLDXF version 2 for the US and version 1 for Canada. That had to be modified, so it was updated, integrated into it. But Richard, it also has a great example of a relational data.
Richard, yes. We lost your audio for a minute, so you might want to go back and repeat the last couple of sentences.
Yeah, so CLDXF, US and Canada, and forgive me, folks, if I have a drop in bandwidth. It's not the best it could be here where I'm in Northwest Central Texas. The CLDXF is great. The Appendix B integration. Keep in mind that two of the neat innovations for this I3 standard, one is the relational data model example it gives, where we can now support related fields and tables in it's not just a flat file conveyance that Nina had basically started and stuck with for many, many years, but we support that. It also has a crosswalk between related tables and fields to flat file and conversion back and forth between them. So that's a new addition to that document. And there's GIS data templates. So you don't have to create, let's say, your geodatabase design. We'll have those templates ready to go when the data model version 3 is finally adopted and released, which will be later this year. So that's good stuff. Changes from 2 to 3. There have been a lot of changes for attribution, names, use, type. Legacy county ID fields were added to the roads and the site structures. There are many instances where there are legacy county IDs or other administrative IDs, particularly in the US, where we may have a 4-letter designation, or you may be using the census FIPS codes. Those will now be supported, which is helpful. We've clarified the use and purpose of many of the fields that weren't super clear before, And we've resolved inconsistencies between the GIS data layers registry I mentioned that's in the I3 standard and the service earn registry. So basically, we had to cross-relate it to multiple documents. Let's look at the data model step by step. This version 3 is going to have a few things you need to pay attention to. One, I'll say it again, and I'll say it probably again before the end of the call, WGS84 is the format we're going to follow because it's the interoperability we need. We'll talk about what that actually is in just a minute. Case sensitivity. I know you're all fans. Do I need to have uppercase, lowercase, camel case? I'm pulling these statements directly from the document. So basically, we now need to preserve case, because legacy fields specified in the standard must match the casing in the MSEG. That may cause some consternation for folks, but that is now going to be what the mandate is in the new data model. Section 4.1 table, which I've got a snapshot of down there, of some of it, shows you the GIS layer names that are recommended on the left, and then what functional element they're required for. And I've already alluded to that, where you have the emergency call routing function, ECRF, the LVF, GCS, MCS, MDS. We will show you what layers are required by each of the elements and they're required. There will be some which are off screen that are recommended, and then there are others that will have additional layers used for other uses on the far right. That's where we're going to talk about CAD. That's where we're going to talk about planning, utilities. So this is a new table, and this is great if you're trying to get your program administrators or legislators to understand why you need funding to build certain types of data for different functions so 911 works. That's what we want to do. After this presentation, one of your tasks will be to continue to remember this, pass it on, educate others on what you're having to build. It substantiates the need for funding and resources to build and manage this data long term. Now, I've got an example here of services boundaries. I don't know if there's any other layer more critical than having your emergency service boundaries, the PSAP, the ECC, making sure that you've got those boundary lines coincident with each other where they exist at the same place along the boundaries. We don't want gaps and overlaps between these boundaries. So we'll talk about that in a practical example in just a minute. But something I wanted to let you know is the 3 types of services. So we'll have one for the service area, which is your PSAP or ECC, and you'll have 1 or 3 for the responders. I'd recommend you have a police, fire, EMS, but some people may want to try to have all 3 in a single feature class. I think that's a little wonky, but that's still allowed in this new version of the data model. Note that I've got police bold and in blue. The name has been changed from law because we can have sheriff's offices, constables, not just police in basically a police department in an incorporated jurisdiction. But police was most recognized universally across all documents. So that term from law has been converted to police. Keep that in mind. And we'll talk about geodetic and civic queries. Before we leave polygon edge alignment, I wanted to remind you that for our purposes, if I've got 2 segments here, and look at the top left, I'm building this polygon. If you are in North America, your X is going to be negative and your Y is going to be positive in most cases, except for a few places in Canada and otherwise. But that will indicate what we see in the comm centers when a 911 call comes in from a wireless device. That is WGS84 format, that World Geodetic System utilized by GPS. That's why the X and Y is what it is. If you're in Europe, for the most part, your X is going to be positive and your Y is going to be positive. This is why if those signs get switched, you could wind up somewhere in the Sea of Japan. We want to make sure people understand that. These wireless components and the XY in general is important because it's going to be searched directly to the polygons. And that's where this alignment, there's a coincidence of alignment. If I've got a road segment or I've got a boundary on the left which has 2 nodes for a particular line, and I have 3 nodes on the one that's supposed to be right on top of it, I put a space in there so you can see the difference between the 2. If I'm using, let's say, a state plane projected coordinate system, maybe I've got N8083 datum in the state, and I'm going to convert to WGS84, it's quite possible that the conversion process itself will shift those nodes, those vertices, and introduce a gap or an overlap. This is quite common. The way we get around it is that, or deal with it, we have to do the reprojection and check again for gaps, overlaps once data, polygon, and other geometries are getting ready to go into the NGCS system in WGS84, we need to be able to check for those gaps, overlaps, or misalignments after it's in that format. Or we take it out if we've got, let's say, again, an NAD83 datum, and I'm going to convert it to WGS84. I can do that at my local level, correct gaps and overlaps, and then push it up. We just have to be aware that it needs to be built correctly. The way to get around this is to create a zipper approach where I've got paired up vertices or nodes for every one of my geometries that are right on top of each other. Okay, and we'll talk about that in the industry as we go forward, but that's one of the biggest geometry problems we're going to have throughout Colorado. Now, again, I've put in bold blue on the top left. This is a snapshot. I've updated this. This is a table for the site structure. There are several things I want to call out to you, and we'll see this in a little more simplified form. There are attributes used in routing a call from when it comes in to the network to where it needs to get to the PSAP or ECC. And that's in the red boxes. That's going to be all the components of the street name. I want you to note in that middle column that says required, third column over, right in the middle of each of these two segments. This is one table. I just couldn't fit it all in one. We got rid of optional. There is no optional field in these tables, these schemas for address points, row center lines, all this. We have required. It's either required or not, or it's conditional. Now, as you probably already guessed, if it's not required, that's our new optional, but we got rid of the term optional. If it's conditional, it's required if there's data to populate that attribute or it's necessary. Note here that we've got various administrative levels, state, county, that we've got the descriptive name on the left and the field name in the middle. The field name is what's going to be used for conveyance between elements, but the descriptive name really tells you in human terms what the heck it is. Okay? Address number suffix, address number complete. All of these things are conditional, which is odd. I know you're going to think, wow, I don't have to have all the street name components. They're all conditional, because not every location is going to be predicated on a street name. So you'll want to look at this within the data model copy when you get it. We look to the right side. There's something called, again, the MSAC conversion service. We now need to make sure, it's all conditional, that the legacy street name components of pre-directional, name, type, and post-directional, there are only four really, four legacy data that we use today in the ALI and MSAC. Those need to be filled in just like the ESN and MSAC, because what's going to happen, this MSAC conversion service is going to help translate between everything in the red on the left and the purple on the right. That's going to happen within the network. You won't see it, but what drives this is GIS data. Address points, row center lines, as long as those fields are filled in. And I also show you, we're probably not going to see a lot of its use right now, but down the road we will, dispatchable location. The FCC, the Federal Communications Commission, stipulates that dispatchable location, which is not what you think of dispatch in CAD, dispatchable location, that term is reserved for describing subaddressing, where you have the building, the floor, the room. In this case, we've expanded that. We now have floor label, floor index, which are interesting in and of themselves, because now we're trying to clarify what the floor is and what its label may be. Some buildings don't have a 13th floor because of superstitions or whatever. If that's the case, we need to know that the 13th floor is actually labeled the 14th or whatever. So keep that in mind. We have wing that was added and a few other things. So that's been expanded a little bit. And we've made sure that we are preparing slowly to support 3D by having longitude, latitude, and elevation. Three different things. If you're looking at latitude and longitude, there's a nice section within the model that describes it, really hashed out in the 3D REQ. I'm going to move over to the sample attribute definitions. We've really fleshed these out. I pulled two. I wanted to make sure you understood that altitude, taken as an example, will have a description, a domain, what is the range of values that are acceptable. We'll have examples in there, and we argued and used all the people from around the country in Canada really made a great effort to contribute real examples. Note that we'll have a variety of things in here that'll probably apply to you. Some won't, so take what you need out of it. But the description of the data attributes, the data attribute domains, those are real important values. And with altitude, for example, it's the measure of the orthogonal distance from the WGS84 ellipsoid given in meters. We hashed out all these descriptions so you could actually cut and paste what's necessary to help your local governments and some of the people that are participating understand what your needs are going to be. On the right one, we have a left from address. Here we have a few graphic examples to better illustrate, which may not be as easily conveyed in just words. So this is really neat what we've done in the version 3 of these attribute definitions. Now, why do we build all this? Primarily to determine where a call is coming from and where it falls within the responding areas for the PSAP or ECCs. On the left, we have a geodetic location. We're going to mention those two terms interchangeably, geodetic, okay, and civic. Geodetic is going to be the X and Y, short for a wireless phone. See a cell phone icon there? That's going to come in. It's going to query a polygon layer, and we showed you a polygon table for the service boundary. And when it finds that, it's either going to find the correct PSAP URI where it needs to send the call to and all the location information, or it's not. And they'll have to take other means, whether it's default routing or routing it to a forest guide. When we talk about querying a civic location, we obviously can't take a 105 Main Street. It won't know where to put it. It's not a coordinate pair. It's not an X and Y that I can just drop on top of a polygon. So we have to use the address points or road center lines, or both, depending on the software design for the ECRF, to determine where that civic location falls, and then interpolate an XY from its location on a point or its location along a road segment through geocoding. That then is compared to the polygon layer to do a point and polygon intersect. These two diagrams are in the utilization document I mentioned that I'm co-chairing that are very helpful. We had some great contributions from folks to build these graphics out. So we're building documentation as fast as we can that really illustrates not just for what you need to know, but people following up in your shoes as time moves on. When we look at the data model site structure address point schema for LVF and ECRF use, as we mentioned, again, what I was just talking about here, where we're doing the point and polygon search, there are some application designs which will leverage primarily the attributes, not necessarily the geometry. For example, if you have a road centerline segment that is wholly contained within only one PSAP or ECC boundary, then you don't need a geocode because they all get routed the same way. There are ways we can speed up the routing determination for calls by using attribution in addition or instead of the geometry. Just wanted you to be aware of that. And later on, when we find that, let's say, a school campus or a golf course or some other large extensive development is broken apart by geographic limitations, a river or something else, that may affect who responds to that geography. If that's the case, we may need to know what building it's in or what floor it's on. We have the option in NextGen 911 to use dispatchable location sub-addressing for that. And what I'm seeing in Florida and other locations, there is an effort to start that process by having at least buildings, let's say with an apartment complex, having different units within a mobile home park or manufactured housing development, have that sub-addressing location. It's a lot of work, but it could be useful in the future. So we've accounted for that in the data model. Now, the location validation function, any data that's built that's going to be utilized for this purpose has to be vetted in a location validation function. When we create new addresses, and today, when you create an alley record, automatic location information, you're working with your telephone company, your service provider, and you're entering those, and the master tree address guide constrains it to make sure it's going to be valid. We have to do that with GIS data in the future in new locations. New locations issued, it has to be checked against GIS data. And when it does, it's going to do an attribution check, and it's going to look for valid versus invalid versus unchecked. So we go back to these attributes. If I'm going down left to right, and I'm looking for the street name post, post type, looking at street name post modifier, all these things. If I'm going through the street name pre-modifier, all that stuff is going to be handled as whether it's checked or unchecked. And in this case, we're going to have, it's only going to tell you if it's valid, invalid, or if you turned off checking for a certain value. It will not tell you how to fix and check and fix the data. It's not going to tell you why it's wrong. It's only going to tell you where it stops validating. This is important, and this is described at length in the NINA informational document 027. I recommend if you're going to want to know how your GIS data is going to be used for validation, you should check that out. Okay. Also, the i3 architecture, document I mentioned talks about the MSAC conversion service. Understand that conversion, and I've tried to create what's very simple understanding. Basically, Section 4.4 in this I3 architecture document describes the web service that provides data to or gets data from a non-upgraded system or center still uses MSAC data, legacy data. It provides that conversion between next-gen PIDFlow and legacy MSAC data. And it's either going to do a PIDFlow to MSAG, where you got a next-gen site transferring to a legacy technology site, or vice versa. When that happens, for your IT people, there will be the potential for that not to work. Maybe it's outside the data available, or it's malformed, it's not formatted correctly, something happened in the network, there was data drop. So you have different codes I put there as an example, where it may be a temporary redirect, maybe the system's not, the MCS is not available, there's an outage, no address found. So anyway, all of this is covered in Section 4.4. But I wanted you to be aware that that is something we'll have to know. And guess what? That will create a discrepancy report if we're unable to convert a location using your GIS data. For that MSAT conversion, it's real important to understand that your GIS data, in this case I'm using site structure, but it's also road center lines. We need both. They're both required. In NextGen 911, we'll use that conversion from the red to the purple here, or from the purple to the red, depending on which way we need to do the conversion. So remember all those fields that are not required, but they're conditional? Guess what? They're required for the MCS. So you got to look at the conditional under the requirement field as, well, it's conditional, depending on whether you're going to use it for the MCS or not. You may already be getting the idea that your GIS data is going to be multitasked with usage. You're right, it is going to be. We take it to geocoding service. For those of us who had to build geocoders or had to utilize them, it's going to require a little forethought. So I wanted to put this in here so you didn't have to go look it up. In Section 4.5 of the I3 architecture, it describes how geocoding has to be performed and reverse geocoding. Okay, so on the geocode stipulation, it'll locate a civic address represented by the input PIDFlow. The PIDFlow is what the CLDXF is. It's another way to describe it. The PIDFlow is the actual, think of it as the transmission format itself for what that civic location data exchange format is, all the different fields and values acceptable in it. And it finds a match in the site structure address points or road center lines. Okay. Once it does, it obtains a geodetic location. I mentioned this before. If I have an incoming location and I'm going to geocode, I'm going to take the incoming 105 Main Street and geocode a location on a point or road center line and say, okay, I know where that falls within the polygon. This just describes in detail what that geocode process is. And then the reverse geocode, which converts a geodetic representation, the X and Y, to location in the civic address or PIDFlow format. So it's pretty good. So you've got these descriptions. Go look at 4.5. It'll give it to you in detail. Now I'm going to talk about something that gives me a pain. The I3 standard is dependent upon the GIS data model. The GIS data model is dependent on the I3 standard. That interdependence between the two results sometimes in things we have to do that we may not like. One of them is creating a new unique ID that has to be globally or universally unique for everybody in the United States and even Canada. So in the version 3 of the data model, it's mandated that you have to have a 4-part, F-O-U-R, 4-part taxonomy for your unique IDs. It's going to be made up of a name, a resource name. Basically, the uniform resource name or EARN is something that's going to be provided. You'll have to work with your service provider and other local folks to determine what the EARNs are you're going to use. And then you'll have to have a layer indicator. That's pretty straightforward. And we have a list of all these in the data model. Address points, site structure address points, road center lines. Then you have your local unique ID. That's yours. It's whatever you're doing for your local unique ID. And then an agency identifier. This has to be a fully qualified domain name, FQDN. So that's fairly new as well. When you put it all together, look at that monster. This little guy here will be your new unique ID for one particular GIS feature. Now imagine you're going to have that for every single point, line, and polygon you have. Yes, that will be fun. So you'll have to work with your system administrator. You'll have to work with your software and service providers to make sure they understand this attribute for every single feature and managed. Not easy, doable, but not easy. But it's something that's now going to be required because the data model has to support it because of the needs of the I3 standard. Okay, I'm not going to spend time on 3D today. We've already talked about that in the past. But as I mentioned before, the I3 standard's already putting, height, elevation. It's putting other values in there already supported, and now it supports 2D polygons. So that'll be helpful. And we can talk about 3D another time in detail if we need to. The data stewardship for NG911, I want to remind you that the stewardship, the data model deals with attribution and schema design. The stewardship deals with the geometry. I've got a screenshot here on the right where we talk about layer dependency considerations. You can't read it, but you will when you get the deck and you go look at the document yourself. It's going to describe how to build basically road center lines and how to deal with polygons, not site structure address points. I have found out that we are not going to add site structure address point considerations to this version of stewardship. I mentioned earlier in the presentation that the next step for the data model, this is V3 coming out. What's going to have to be developed in the next few years ahead will be a version 4, which will be fully 3D supporting. When that happens, we'll have to reevaluate and probably update this stewardship document from a 2D line and polygon guidance document to a 3D guidance document. So keep that in mind. Remember, I mentioned there's a 3D structure standard group effort underway right now. I think they met the first time last Friday. I mentioned that. So this will all have to be part of these considerations. But for your purposes, this is a two-dimensional oriented document. It's going to tell you how to build. It's going to talk about accuracy and database precision in detail, but it's going to talk about the road center lines, section 5. Those are going to be the civic location layers. Remember I mentioned that an incoming location has to be found. If it's 105 Main Street or what have you, you have to find it on the points of the roads. It's going to talk about not only the road center lines, but a phased approach of how to get your data from where it is to that point. Emergency service boundaries, talk about emergency service numbers or zones. It'll talk about how to take those layers and how to create what's necessary where we talk about some of these boundary lines. Okay, so keep that in mind. Long-term maintenance of NG911 GIS data, it'll talk about that. Again, site structure address point, not in there right now. As the 3D model comes forward, we may add that in there. Got a little bit of eye candy for you, some things that are going to be called out. The document is graphic rich. Again, this is the GIS data stewardship document. Note that where to split roads, single multiple polygons, cul-de-sacs, coves, driveways, geometry intersections, a lot of things that I think are important, particularly spatial gaps and overlaps. Look at these graphics. You'll see, for example, these are come right from the document. The top one on the left, you're talking about a fishbone where the red points represent the actual address locations. And if you were geocoding that location, the little blue triangles that each one's pointing to, that's where it's going to geocode to. This document will tell you the pros and cons of how you build your data. And this is where I have to remind all of you that when you build GIS data, you're building in the information that helps with decisions by the next-gen core services systems that we're trying to feed data to. So when you place a point, when you draw a road with ranges, keep in mind that that information is going to be used by the system and will inform the system on how it should act. For example, in this example, we have 101 to 199, 100 to 198. Nice buffered range, right? And that's great if I'm trying to match it with another data set. But if I'm geocoding and that road's a mile long and the last address on it's 111, it would geocode down here, not where it actually is, way up on the other end of the road. So you have to keep in mind what's happening on this stuff. Sorry, folks. Keep that in mind. And these graphics for gaps overlaps are very important as well. What I will also tell you is that since it only covers road center lines and polygon boundaries, make sure to look at the site structure address point INF that we built a few years ago. This talks about how to place a point given any address. I was part of that, one of the co-chairs of that group. It took us
Hey, Richard.
say it took us a couple of years, and Sears all. Yep. Did I drop out again?
You did. It's
Am I back?
fine. You dropped out right after you said it took us.
It took us 2 years
There you
to
go.
do that. So we've got that going. Make sure that you look at the site structure address point document, INF, because it talks about how to deal with address point placement for geocoding, parcel, site structures, property address. We have best practices in there. Subaddress we talk about. It's a really good document. And now that I've found out a few weeks ago, it will not be incorporated in the next version of the stewardship document. It will be your guidance on how to place a site structure address point in your GIS data for that feature class. Okay. So you'll use this in conjunction with the stewardship, GIS data stewardship document that covers linear features, road center lines, and polygon features. Okay. So you have two documents to look at together. And this is the SSAP document. I want to talk for a minute here as we round the horn here on synchronizing. I pulled this out as a reminder to what we're trying to aspire to. NENA 71501, this document, which came out in 2009, was latched on to by many jurisdictions as the minimum that needed to be performed to build GIS data consistent as a necessity for next-gen 911 use. That's true to a degree. This was built before we had a data model, before we had stewardship, before we had anything else. So in that vacuum of no guidance, NENA developed guidance and said, okay, let's make sure that your GIS data at least covers your existing legacy addresses and road ranges, names and ranges. They did this by saying, okay, let's make sure that your alley is covered by your site structure address points and your IMSAG ranges, right? Street and ranges 100 to 199 or whatever, that it's covered by your GIS road center lines to at least 98% match. This document's pretty extensive and goes into a lot of detail of how to do that. What I want to bring to your level, to your attention in the blue bold is street level versus block level understanding of how this is accomplished. Many jurisdictions around the country are looking at how do I hurry up and get my GIS data ready. Some of them will do a cursory survey of the data, basically say it's fine for what it needs to be. It'll all clean up in the wash. It'll fall out when we get it implemented. That runs us into problems. If you want to do a street level where one MSAG may match many RCLs, that's a way to see that you covered all your MSAG records with at least RCLs as a basically an aggregate. There's another way that's happening. I want to warn you against this, where there's block level, one MSAG to one RCL. We have seen a retrograde movement in some places where people have been taking the ranges of their road center lines and expanding them to buffer, to blocked ranges, so that they have a nice match. One MSAG matches one road center line, and they do that by expanding the road center line one segment with the full 100 to 198 range as an example. That hurts your ability to geocode accurately. That has a negative impact on the efficacy of your data in the next-gen core services. I want to warn against that. We've seen that in several places where people are more concerned about hitting this 98% match, which again, that's only for the ALI and MSAG records, than they are about making sure the data is usable correctly within the NGCS. And I think we've illustrated some of that today. Also has to go without saying that if you're preparing your data for this synchronization, that you're going to have to parse out all the fields, and that the MSAG records should be found in the GIS with the following exceptions. Your MSAG is going to have other data records such as fictitious or FX records. You're going to have test records. You're going to have VoIP records, wireless shell records. Those will not have a match. That will negatively affect your desired 98% match. And a lot of people will excise those records, and that's not the way to go either. So They're used for a purpose today. Bear in mind, what you add or take out of your GIS data has an impact on other purposes. In all cases, look at 71501 to understand what it's trying to say. And again, one of the things it does say that I'm a huge advocate for, it does say you want to do a down and dirty quick check, run your alley database records, right? Remember, your alley could have multiple telephone number records, but a singular address. Run your alley address locations against your GIS data, primarily your road center lines. You do that, and you're providing the road center lines, you're going to catch most of the incoming calls in your NGCS. So that last item, I would heartily recommend. The basic steps as outlined in that document is you're going to have to look at data preparation, standardization, and then initial corrections. This is the process. It's not an easy lift to get that 98%. This is what you're supposed to do if you're actually going to synchronize. Most places are not. But this is what, if you're going to say you're 90% compliant, this is what you should have done to get to that 98% compliant. And I would tell you probably at least 99% of the people I talk to that say they're 98% compliant have not followed that process on the left. It's just a lot of work, particularly if you're going to ditch the ALI-IMSAG someday. On the right, those two graphics that come straight from that document, you'll note that everything in the red had to be changed to make it the way it is on the right in the green. That's a lot of work. And you're supposed to check and correct not only your GIS data, but legacy ALI-IMSAG records. So you're consistent both ways. A lot of work. As we get near the end here, there's a data transition document. I find this particularly helpful. They took a long time, and that's NENA INF 46.1. That came out last year. It covers who is responsible for building and managing GIS data in the E911 world that we have everywhere today, the transitional world many people are moving into, and the next gen 911 world. So when we talk about, let's say, the IMSAG coordinator, that'll be the third, fourth, and fifth roles. Note that they have a role in E911 as they always have, and in transition, but that role may change in next gen 911 to more of a GIS role. We want to make sure we're not leaving people behind. So cross-training, getting people ready for the inevitable full transition to in-state NG911, which won't happen for a long time. We want to make sure that they're feeling comfortable, because GIS and NG911 is really just the next version of IMSAG coordination today. And you're going to have to do both in a transitional state side by side for a little while, everywhere, at least initially. In that transition document, don't underestimate how that data is used in both roles for E911 and NG911. There's a table I pulled an extract off that shows you how that data transitions between them. It provides a three-phased approach. A first phase of creation of the IMSAG community ESN ESC polygons, a second phase for legacy database synchronization, which we talked about, and a third phase for NG911 readiness support and GIS-derived IMSAG. This is one of the examples from that document. We have to create, using legacy geometry and geography, such as emergency service zones, which are a reflection of the ESN coverage. We have to be able to take those and create PSAP and ECC coverage areas. We have to be able to take through dissolves or merges of certain polygons for ESNs and ESCs into the more appropriate responder boundaries necessary for the next gen 911 GIS data model. In some cases, people will maintain both the ESN layers because it's used by CAD or it's used in their map displays or whatever, and then they'll do a dissolve when they need it for their next gen systems like the LVF or the ECRF. And that's fine too. You can manage both, but just bear in mind that you'll have to do some dissolves or merges to create the final layers you need for response. That's going to be for where to route calls to for the PSAP or ECC, as well as the responders themselves. I will wrap this up by letting you know that the utilization of GIS data in Next Gen 911 core services, the work group I oversee, we're dealing with a lot of information. Everything I've been talking about here, we explain in detail, written word as concisely as we can in a nice, organized way by functional element. So all those acronyms I showed you, the ECRF, the LVF, the SI, the GCS, every section in that document will describe it in human understandable terms, hopefully, in a concise way, and where necessary, refer to other documents that have more technical details. We'd also discuss accuracy and precision. That's a subject that we've been bandying around within NENA for a while, and that's something we discuss in it as well. I wanted to leave just a few minutes at the end if there's any questions. Again, this deck is yours. This is not meant to be an all-inclusive discussion. It's meant to let you know where the GIS data model v3 is, where we are on the transition process with regards to the transition document, also the I3 standard that everything is dependent upon, and how this is all progressing this year. Remind you again, the I3 data model will be coming out shortly in a few months. The utilization of GIS data in the next gen core services. If you're interested in joining that work group, you can reach out to me. Let me know. Glad to provide you information on how to join our effort on that. That's going to be underway for some time. And the I3 data model, sorry, the I3 standard architecture standard group, always taking volunteers to help. They will be working on their work for a while. And if you're interested in the 3D GIS modeling group, that standard that's just now starting, let me know as well. We can get you tied into that. So contact information here. Uh, Myself, you see that's my phone number and email. Please feel to reach out. Jeff Young, I think Jeff, you're still on the call. I think that's his contact information as well.
Thank you so much, Richard. And I'm sure we've got some questions. So don't be shy. Go ahead and raise your hand and unmute and ask the questions because we do have a little bit of time. Thank you.
And if not, if you don't want to voice it, we can always answer them after the fact too.
We can, but why? We have the experts here.
Sometimes this gets a little overwhelming, even for me, when I talk through it.
Well, and I will say, if you have a question, then I guarantee you somebody else on the call has a question. So go ahead, Rachel.
Hi. What states, if any, have gone to I3 location validation for their spatial routing at the state level? And number two, are there any states that don't have to maintain their legacy MSEG any longer?
Great questions. There are several states that have been working on that and towards that. I know that there are states such as whether it's Utah or dealing with Arizona or other states, Minnesota, Michigan, states that I know we've worked in, that we've made sure their data is ready to go, but they may not be implementing some of the LVF, ECRF. I can give you some sites that I know I've worked on where they've done that after the call, but I will tell you that for the in-state validation and call routing, that is not widely done across the U.S. at this point. There have been a lot of forays into that. If you look at California and some of the other areas, they are moving towards, how do I say this, making sure their deployments are strong and adjusting through experience as necessary. Many states have done a good job at standardizing data. If you're looking at Kansas or Arkansas or others, they're doing really well at getting statewide data preparatory to doing state-run LVF ECRF. What I will tell you is several states are in the middle of an RFP process to acquire and establish that. I know that South Dakota just completed one. Colorado had a process for that, parts of it. Florida is working on that almost in collective groups, consortiums, if you will, rather than a statewide organization. It really depends if each state has a very strong organization or it's broken up. Texas, for example, has three types of 911 governance. It has a state level governance program, which oversees maybe about 70% of the geography, but 30% of the population. The rest of the area is governed by either districts, 911 districts, or home rule cities. So it really varies across the country. But I am not aware of a lot of up and running implementations that are ongoing in state. And for me, in state means not only implementation of the LVF ECRF, but also discrepancy reporting and remediation. I will tell you, to answer the last part of your question, we will not see the ALI MSAG go away for some time. And many implementations for next gen they are utilizing MSAG or GIS data derived MSAGs for the database to use in the initial implementations, if not longer. So I can see us running them side by side for a while.
Awesome.
Hopefully that helps.
Thanks, Rachel. Who else has a question?
And again, we're glad to answer them after the fact if you want. Just let me know if you've got anything else. Again, we want to thank the state and the work being done by you folks helping us present all of this.
Absolutely. Well, we're really grateful for the presentation. So thank you everybody who was here in person, and we will post this up on our YouTube, and we'll have the next session coming up here in a couple of weeks. And thank you all very much. Enjoy the rest of your day.
Thank you, everyone.